Yeah, we didn't have the time to prepare that much, so yeah, so don't worry too much, right?
Yes, sir.
Okay. Yeah. So, what are the preliminary that we will use? One is that we know what is electric field, right? So, electric field, whenever you have some charge, right? So, at this point, or at this point, or at this point, so the region outside or the region around this charge, we will experience some electric field, right? So, let's say this is E2, let's say this is E3. So this is the definition of the electric field. Region around the charge where we can experience the electric force. Okay. And the next one is that we know what is Coulomb force. Okay, so we know what is Coulomb force, that you have two charges, right? You have two charges and they will exert some pressure on each other, force on each other, right? So this is Q1, this is Q2, this is separation R. So they will experience this force, right? So this is the Coulomb's law. And the third one is that the geometrical structure of the electric dipole. Okay, so you have this dipole, and this has a very small separation 2a. Okay, so and the dipole moment, which defines the strength of the dipole, it goes from negative to positive. So this is the dipole moment. Okay, and whose magnitude is the charge, magnitude of charge into the separation. Okay, so these are the preliminary for the electric field of dipole due to axial point and the equatorial point. Okay, so 2qa, right? So now we will use this, and I will not derive in this class because I have already derived this. So whenever I will be giving the backup class for Saad and Mariam, so then I will derive those. Okay, guys, just
Okay,
bear
sir.
with me. Yeah, so just accept the formula for now, and then we will discuss how this comes. Okay, so we have this dipole, right? We have this dipole. This is the separation 2a, right? And this is the line of the axis of this dipole. Okay, so if we want to calculate the electric field at this point, this will be called the axial point. Okay, and you guys already know the vector formula. So if I move in the x direction, what would be my direction? Yes, if I move in the x direction, so what would be the vector that represents the x direction? Yes, guys.
The I can.
Yes, I hat or I cap will describe the direction in the x direction, and j hat will describe the direction in the y direction, and k in the z direction. So this is about this direction, right? So we have this dipole moment in this direction p hat, and we want to calculate the electric field at this point. So this will be the axial point. So if we calculate the electric field, this will come out to be in this direction, right? And the magnitude would be 2 kp by r cube, right? And if I write it in the vector form, so this would be the direction. So you can see that the axial electric field due to the dipole is in the direction of this P. Okay, so just for now, just accept this, guys. Just accept this. I will derive at some point with you, Mariam and Saad. I will derive this for you. Okay, in the backup class. Yeah, so just remember this, that at the axial point, the direction of the electric field is in the direction of the dipole moment. Okay, am I correct, Aisha?
Could you repeat?
Yeah, so the direction of the electric field at the axial point is in the direction of this dipole moment.
Yes.
Yes. Is this correct, Aisha?
Yes.
Yeah. And the perpendicular bisector at this point, right? Perpendicular bisector at this point, which divides this line into two parts, A and A, right? So if I want to calculate the electric field at this point, so this will be called the equatorial point. Okay, and the separation is counted from this point, middle point. So this is R here, and this is R here. Okay. So electric field at this point will be in which direction, Aisha? Do you remember? This is the direction of the dipole moment. So the electric field at this point is in which direction? Yes, Aisha, do you remember? Did you revise? Yes, Aisha, can you tell me? You remember or forgot or yeah.
In the upward direction.
Yeah, can I repeat the question? Yeah. So I am calculating the electric field at this equatorial point, right? The perpendicular bisector, right, Aisha?
Yes, sir.
And I am asking that whatever you derive the electric field at this point, so what will be the direction of the electric field at this point, at the equatorial point? So do you remember? We calculated the electric field. Just remember the
Opposite to
expression.
the dipole.
Yes, absolutely right. Yes, very nice. Yeah, so this would be the direction of the equatorial. Right, Aisha. Yeah, so you are correct. And what was the expression? The expression was this. E equatorial was minus of Kp by RQ. Right. Okay, guys. So these are the two expressions. For the axial point, the electric field is in the direction of this dipole moment. And at the equatorial point, the electric field is against the direction of this. So this is the direction. For this case, this is the direction, axial, and for equatorial, this is the direction. Okay, guys, so this much clear. Just accept the formula, or and is this funda clear? Mariam and Saad, is this are these points clear?
Yes.
Okay. Yes, Saad, clear? Any doubt? Just
No,
get
sir.
out
No.
of that exam. Yeah, just get out of, just forget that exam. Okay.
Yes, sir.
Yeah, okay. And don't think about that exam. So just think about the next exam that will come. Okay. Yeah. So now we know that what is the axial electric field due to dipole, right? This is 2 Kp. This is 2 Kp by RQ. Okay. And the equatorial is minus Kp by RQ. Right. So there is this question which says that we have to find, right? So we have, if we have 2 or 3 electric field, right? So what would be the total electric field? Can you guys tell me? Yeah. So what would be the electric field due to multiple charges? Yes, Aisha, what would be the electric field due to multiple charges?
Um,
Yes. What did you say? Did you say vector sum?
I don't know.
So your voice is not clear. Can you repeat that? Sorry. Can you repeat that? Yes. What did you say? Yeah. Okay. So that would be vector sum. I assume that you said vector sum. Yeah. So vector sum meaning superposition principle. Okay. So we have this question, which is so there are two electric dipoles, right? One is this minus Q and Q. Okay. So one is this, right? And the separation is two-way, right? The dipole moment is P, right? And there's this another dipole, which is like this, plus Q and minus Q. So it has the same separation. Okay. And the dipole moment would be this or this. Which would be the dipole moment? One or two? Mariam.
Two. No, one.
Yeah, one. Yes, one. Okay, so this would be the direction of the dipole, right? And we want to calculate the electric field at this point. This is the point that we want to calculate the electric field. Okay, and this distance is same. This is R, and this is also R. So diagrammatically, it is not looking like the same distance, but my diagram is bad. So this is the same distance. Okay. So we want to calculate the electric field at this point, right, guys? So that would be the vector sum of the electric field due to this setup, this system, and the electric field due to this setup. Let's say this is E2 vector, and let's say this is E1 vector. Okay, so the electric field would be how much? Vector sum. Right, guys?
Yes, sir.
Yes, yes,
Yes, sir.
yeah. So, yeah, so first let us calculate what would be our E1. So this is the dipole, right? And this is what line?
Axial.
Axial, right? This is axial line, so we have to calculate this thing. So the electric field will be E axial due to this dipole at this point. Right, so this is E1 is E axial 1, let's say. Right. And can you guys see this? So this is the dipole, and we want to calculate the electric field at this point. So this is what point? Yes, Mariam, can you tell me this is what point? Due to this dipole, this is what point? So let me draw the diagram. Yes, yes. What are you saying? Yes, what are you saying, Maria? So
It's equatorial.
equatorial. Is this perpendicular to this bisector, or is this in the line of this axis? Yeah. Just think about that and then tell me the answer. Yes, so equatorial is this, right? When you have this charge and this is the perpendicular one. So this is the equatorial one. And this is the axial one in the line of this dipole, right? So is it in the line of this dipole or perpendicular to this line? What is that, Mariam? Hmm?
Perpendicular.
No, this is the dipole, right? So what is the line of this dipole? Axial line. This is the line, right?
Yes, sir.
So this would be axial point or the equatorial point?
Axial point.
Axial, right? Axial and in this direction. Okay, why this is not working? Okay, what happened to the? Okay, so let me share again. I don't know what happened. Yeah, so Saad and Aisha, did you understand that why this would be axial? The second one?
Yes, sir.
Yes, guys. Yes, Saad and Aisha, did you understand that why this would be axial?
Yes, sir.
Yeah. Yeah. So the second one would also be the axial one. So can you guys see my screen?
Yes, sir.
Yeah. So this is again the axial one, right? So this is E axial 2. Okay. So the total electric field, net electric field would be net electric field would be E axial 1 plus E axial 2. Right, guys? So what is E axial 1? E axial is this. Right, guys? This is E axial. So what would be E axial 1? Yes. Yes. Can you anybody tell me what would be E axial 1? So we can write, so we can also write this as 2 kp magnitude p hat direction and then rq. Okay, so we can write this way also. So this is the magnitude. Okay. Yeah, so can you guys now tell me what would be E axial 1?
2 kp by RQ.
Yeah, 2 kp and p hat, let's say, by rq. So what is p hat here? What is the direction of p hat here in this case? What is the direction of p hat?
X-axis.
So direction, x-axis, so
I, right.
I hat, right? So this would be I hat. Okay, so now you guys can tell me what is E axial 2. Okay, Saad, tell me what would be E axial 2, this one. Yes. Yes, Saad, tell me what would be the E axial 2 vector? Yes, Saad, tell me. Any
I
guess?
don't know, sir.
You don't know.
Maybe
So yeah.
minus Q.
So this is E axial. And what is E axial? E axial is 2 kp and p hat by rq. This is E axial, right? This we know. Right. Understood, Saad. So this we know, right?
Yes, sir, you know.
So this would be 2 kp and p hat is in the direction of what? Yes. So p hat is in the direction of what?
Y axis.
Yeah. So this would be what direction?
Y cap.
Yeah. Y cap is represented by which unit vector?
I.
I is this x direction, right? Y is, yeah. So
J,
you
I
have
guess.
I, yeah, J is correct. Yes. Okay. So this is our net electric field, guys. So E net is 2 kp by r cube I hat plus 2kp by r cube j hat. Okay, so this is our net electric field. Understood, guys? Mariam, Saad, and Aisha. Understood?
Yes, sir.
Yes, sir.
Okay, so if I tell you what would be the magnitude of this E net. So you guys have already learned this vector. So if we have this vector, let's say if we have this vector A, which is AXI plus AYJ. So what is the magnitude of A? Yes. Do you guys, so we have discussed this vector part with some extent, right? We have explicitly talked about this in detail about the vectors. Don't remember, guys.
Okay.
So A magnitude would be, right. So let's say you have this vector, which is 3i plus 4j. So what is the magnitude of this vector? This is this, right? Do you guys remember?
Yes, sir.
Yeah. So we have this something x component, something y component. So magnitude of E net would be, this would be root of how much? Yes, root of this square, right? Yeah. So this kp by r cube square and this much. So 2 kp by r cube square. Okay, so this is common. We can take it outside, right? So this would be 2 kp by r cube. And this was square, so this was root. So if it come outside, so this would be only this. And this is root of what is left here. I have taken the square outside of the root. So what is left here? Mariam, what is left here?
2 kp by r cube.
No. I have taken the square outside. So let's say, okay, so I have just ate one step. So let me write that step. Okay. So let's say that I have taken this common 2 kp by r cube square common. So this would be 1 plus 1. Right? Am I correct? So I have taken the square common, whole term common. So this would be 1 and this would be 1. So this is 2, right? And if I take 2 outside, so that would be 2. So this is 2 and 2, 4, right? Okay, so this one is square. So this would be 2 kp by r cube and this would be root 2. So this would be 2 root 2 kp by r cube. Understood, guys? Yes, guys, any doubt, any question?
No, sir.
Okay, so just note it down and then I will start the next topic. So where should I put the screen? Yeah, so this was the question. Let me draw the question again, right, so that it becomes clear to you guys where, yeah, so let me draw the question here.
So what is the heading for this?
Yeah, what is the?
What is the heading for this?
What is the heading? Okay, so this was a question. So the heading would be electric field due to dipole. Right. And this, so we have learned about this equatorial and the axial part. Right. So after that, this was the question. Question was that we have two dipoles, right? And the separation is 2a. And the other dipole, which is here. So This is plus Q, and this is minus Q, and the separation is also 2a. So we want to calculate the electric field at this point. So calculate electric field at point P. So this is the question. Okay, and this is the answer. So just note this down, guys, and then I'll start the new topic. So if Mariam and Saad, you guys didn't understand this part, so just for now, take it as of now, right? Just take it as granted. And in the backup class, I will discuss this more explicitly, right? So I will discuss this in detail, the axial and the equatorial part. Okay, Saad and Mariam. If you guys didn't understand this part, so then not to worry. I will discuss this again. Okay.
Okay, sir.
Yes,
Yeah.
sir.
Yeah. So just note down, guys, and then we will understand the next topic. So in this question, you guys have to remember what is the electric field at the axial point. So two things to remember: what is the electric field at the axial point, and what is the direction. So these two are the important things in this question. And if you know that, so this question will be easy for you. Yeah, Aisha, so do you have any question?
No, sir.
Okay. So whenever you guys need me to scroll down the screen, please tell me, then I'll scroll down the screen. Yeah, guys, noted up to this point.
Yes, sir.
Okay. Yes, done, guys.
Done, sir.
Yes, Mariam and Saad. Noted. Yes,
Yes, sir.
guys. Mariam, done.
Yes, sir.
Okay, so let us move on to the next topic, which is electric field lines, right? And yeah, so why do we need this electric field lines, right? Because we know about this electric field, so why do we need this electric field lines? Yeah, so first thing is that this is a hypothetical concept. Electric field lines is a hypothetical concept, right? And why we use this concept? To understand the behavior of this electric field, right? So to understand the behavior of this electric field, so to first is that this is a hypothetical concept, right? And second thing, why do we need this? To study or to understand the behavior of electric field. Okay, so that is why we need these electric field lines, right? So there are some peculiar properties of electric field lines which we'll study further. So first thing is that what is the definition of this electric field line? Right. First is definition. So first definition would be that it is a pictorial. It is a geometrical or pictorial representation of electric field. Right. This is one definition. Or we can say that, it is a curve whose tangent gives the direction of electric field. Okay. So what do I mean by this definition? Right. Let's say you have this curve, right? So this represents some electric field lines, and if I draw the tangent at this point, right? This is how this line goes. So this is very important. This arrow is important. This curve is important. So let's say I am at this point, right? So if I draw the tangent at this point, so this would be the tangent. So this tangent will tell me that this is the direction of the electric field, right? So at this point, what would be the direction of the electric field? Will it be this? Will it be this, or will it be this? So let's say E1, E2, E3. Which will be the direction of the electric field at this point? Yeah, Mariam. E1, E2, or E3?
E3.
Yes, correct, Mariam. So this will represent the direction of the electric field, right? So that is why these electric field lines are very important to understand the behavior of the electric field, right? And there are some properties of this electric field lines. So let us understand about those property one by one, right? So the first property, the definition, right? So the properties of Okay, so before I move here, you just guys just note down this part. Okay. Okay, this is whenever you guys have noted, please tell me, then I will move ahead. Okay.
Done, sir.
Done. Yeah. So Aisha and Saad, done.
Yes, sir.
Yes, sir.
Okay. So properties of these electric field lines. Right. First property you already know the definition, right? That tangent to the electric field lines gives the direction of the electric field, right? Okay, guys. So there is a special case that it says. So what does it says? Let's say that you have. So this represents some peculiar scenario, right? Let's say that you can't, or so this says that you can't have an intersecting electric field lines, right? So this property suggests that if you have two intersecting electric field lines, right? So that is prohibited. So this says that you can't have an intersecting electric field lines because it will represent two tangents at a point which will show two direction of electric field, two directions of electric field, which is prohibited. Okay, so let us understand this figuratively. Right, so let's say that you have these and these intersecting lines. So at this point, you will have this electric field, right? And this electric field. So there are two electric fields, which is absurd, right? So this tangent prohibits that you have two intersecting electric field lines. Understood, guys?
Yes, sir.
Yeah. So this is the first property, and which prohibits two intersecting electric field lines. Okay. So just note this. Yes, whenever you guys have noted, please tell me. Then I will. So then I will tell about the second property.
Done, sir.
Yes, Saad and Aisha, done.
Done, sir.
Yes,
Yeah.
sir.
Done. Okay. So the second property is about this density of the electric field lines, right? So relative density of electric field lines represents the strength of electric field. Right. So the denser region of electric field lines will represent high electric field and rarer region of electric field lines will represent low electric field. Right. So let's say you have these so at this point, you see that the electric field lines are denser, right, guys?
Yes, sir.
So let's say I am calculating the electric field at this point, and I am calculating the electric field at this point. Let's say this is point A and this is point B, right? So at point B, the density is very low, right? And in point A, the density is high. So I can see that electric field at A point is larger than electric field at B point. So did you guys see that we represented some lines and then we were able to say that what is the direction of the electric field and what is the magnitude of this electric field, right? So by just the concept of this electric field lines, we were able to tell the direction and the magnitude of the electric, right, guys? So geometrically and pictorially, we represented the behavior of this electric field. Understood, guys?
Yes, sir.
Yeah. So you are saying no, sir, or yes? Aisha? Yeah. Yes, sir. So please note down this part, guys. This is point A only, right? Ah, whenever you guys have finished noting, please tell me. Then I will do the next part.
Done, sir.
Done. And Saad and Aisha, done.
1 minute.
1 minute. Okay. So
Yes,
after,
sir.
yeah. So after this class, you guys will have an assessment test. whatever you have learned in this class. Okay. So please be here and just take that test. Okay. So that will tell me that how much you guys have learned, right? So that will tell me that how much I was able to make you understand, guys, right? So that will be the test of mine. Okay. So after this class, just after this class, please be here and take that class assessment test. Okay, guys.
Yes, sir.
Yeah, Aisha already know, right? So Mariam and Saad, please be. Okay, so the next property is you guys are already familiar with this property, right? That if you have so if you have a positive charge, the electric field lines goes outward or move away from the positive charge, right? And if you have a negative charge, right? So the electric field lines will be incoming, right? So what do I mean by that? So let's say that you have this positive point charge, right? So this is positive charge. So positive charge, this will be outward. The electric field lines would be outward. Okay, guys. And for the negative charge, the electric field lines would be inward. Oh. So remember, this arrow is very important. Okay, guys. So you see that if you see that, what are the number of these electric field lines here? What is the number? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count it correct? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 electric field lines here. And how many in there? So you have 1, 2, 3, 4, 5, 6, 7. Okay. So the number of electric field lines also tells you about the as I've talked in the previous property. So this tells you about the electric field strength, right? So the magnitude of this charge is higher than the magnitude of this charge. Okay.
Yes, sir.
Yeah. So let me ask you a question that let's say I have this positive charge, right? And there are, let's say this is of 2 plus 2 coulomb, right? So this is let's say plus 2 coulomb, right? So this would be, let's say this is the diagram of plus 2 coulomb. Okay. So if I want to draw the same charge which has 8 coulomb charge, right? 8 coulomb charge. So what would be the electric field lines? How many lines would be there for the 8 coulomb charge? You have 3 lines for this 2 coulomb charge. So how many lines would be there for this 8 coulomb charge?
9.
Yes. So how much it is different from this 8 coulomb charge? Right. So you have multiple of 4 number of electric field lines, right? So you have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is 12. Right. So this will be the number of electric field lines. Okay. So let's say you have this 3 coulomb charge which has two electric field lines. So if I draw the, let's say 9 coulomb charge, so how many lines would be there? Yes, guys. Saad, tell me, how many lines will be there for this 9 coulomb charge? Yes, Saad, did you understand the question?
Yes, sir.
Yeah, so can you tell me how many lines would be there for this 9 coulomb charge? You have 2 lines for this 3 coulomb charge. Right, so how many lines for this 9 coulomb charge?
Um, 6.
Yes, correct. Absolutely correct. So we have 2 and this is multiple of 3, so 6. Right, so absolutely correct, sir. So the charge, let's say this is A, this is B. This is directly proportional to the, let's say, number of the electric field lines. Okay, guys, understood this part?
I have a doubt.
Yes, yes, of course. Doubts are always welcome.
Yeah, how do we know that the electric field lines are going outwards when it's positive and inwards when it's negative?
Yeah, so this says that the electric field lines start from this, yeah, so this says that you have the maximum electric field near this charge, right? And then it fades. Okay. So this tells me that if we have the positive charge, the electric field lines would always go outward in the direction. Okay, so this is the convention that we have. Okay. For
Yes, sir.
negative one, yeah, so for negative one, it will be incoming, and for the, so this is the convention that is there. Okay. Understood. Because we have the convention that the positive charge repels, right? So it goes out of this. So if we have this positive charge and we are calculating the Coulomb's law at this point, so this will repel. Okay. So this goes out from this point. So in that way, we can say that for the positive charge, it goes out from this point. Okay, understood, Maria. Yes, yes, Mariam, understood.
Yes, sir.
So Aisha, you asked the question, right? You or Mariam asked the question. Who asked the question?
I asked.
Oh, you asked the question. Yeah. So this tells me about this. So this outward direction tells me about this repulsive nature, right? And this incoming, let's say this incoming tells me about this attractive nature. Okay. So this is the meaning of this outward and inward direction. Understood, Aisha? Yeah, so this was my next property, but okay, so you guys just so you did you guys understand this part, that the number of the electric field lines is directly proportional to the ratio of the charges. Understood?
Yes.
Yeah, so please note down this part. Yes, noted, guys.
Yes, sir.
Yeah. So, so you see that this third property tells about the polarity of the electric field lines, right? So if you have the outward electric field lines, so that will tell me that the electric charge is positive. And if I have the inward electric field lines, then it will tell me that the charge is negative. So these are so many properties we can tell about so just having the representation of those electric field lines. Okay. So that is why this electric field lines are very important. Yeah. So did you guys note down this also?
Yes, sir.
Okay. Yeah. So let us understand about this. So the next, as Aisha asked, so this was the next property. That okay. So before that, the next property is that the electric field lines are continuous, right? So let's say that you have this positive charge, right? So this will be continuous lines, not like this. So let's say you have this and then this and then this and then this and then this, not like this. So these are not continuous. Okay. So electric field lines are continuous. Understood, guys?
Yes.
Yes. Yeah. And the next property is so the electric field lines, right? So they, if you have, let's say, negative charge, right? So the longitudinal attraction will tell us, okay, so longitudinal attraction will tell about the negative nature of the charge, okay, or longitudinal contraction will tell about the attractive nature of the charge. Right. So let's say at this point, all the charges are at contracting, right? Let's say at this point, contracting. So this will say that this this charge is attractive kind of charge. Okay. Understood, guys? So let's say
Yes.
that, yeah. So let's say that if a charge comes out of this point and then goes at this point, right? So we can say about the polarity of the charge. So this will be, let's say this is Q1, this is Q2. So Q2, what is the polarity of Q2 and what is the polarity of Q1?
Q2 is minus Q and Q. Sorry, Q1 is minus Q and Q2 is plus Q.
So Q2 is positive, right? And Q1 is negative. Is this
Minus.
is this what you were saying, Mariam?
Yes, sir.
Yes, is this what you were saying? You were saying, Mariam?
Yes, sir.
Yeah. So yeah, you are correct. So this contractions, you see that the field lines are contracting at this point. Okay. So this contraction tells about this attractive nature of the electric field lines or electric field. Understood, guys? Yes, understood.
Yes, sir.
Okay, and the next property is this. So the lateral pressure tells about the repulsive behavior of the electric field. Okay, so let's say you have two charges, plus Q, and let's say this is also plus Q, and the electric field lines are coming, right? So this tells that these two field lines are repulsing each other, right? So they are repulsing, they are not coming towards each other, they are repulsing. Okay, so this let's not talk about the polarity area, right? So this will tell about the repulsive nature of electric field. Understood, guys? So if two electric field lines come towards each other and then they move away, right? So this tendency tells about the repulsive nature of the electric field lines or the electric field. Did you guys understand that?
What can you explain about it?
Yeah. So let's say that the two electric field lines are coming at this point, right? But they don't meet and they just repel each other, or they feel a pressure and then they move away. So this is applying some pressure on this line and this is applying some pressure on this line. So they move away from each other. So that tells about that they are repelling, right? They are repelling, which means that this tells about the repulsive nature. Okay, understood.
Yes.
Yeah, so if when I draw the electric field lines due to this positive charge, so then you will be able to understand this more clearly. Okay, so you guys, did you guys note down this part, 4, 5, 6?
Yes.
So did you guys, okay, good. What about Saad? So Saad, did you note down this part, 4, 5? Yes, Saad, did you note down the fourth and fifth property?
Hello, sir. Can you repeat again?
Yes, yes. So did you note down this fourth and fifth property? I just scrolled down. So did you note down this fourth and fifth?
Yes, sir.
Okay, so just note down this 6 and then the last two are remaining.
Okay, sir.
So you guys can see that, yeah, so I think that you guys have noted. So let us write this seventh point, right? So electric field lines don't intersect the, let's say, neutral point. And goes and meet at infinity, right? So what are the neutral points, guys? What is the neutral point for the case of electric field? Aisha, do you remember what is the neutral point? In the symmetry part, we understood about this neutral point.
E is equals to 0.
Yeah, so when electric field is 0, so that is called the neutral point, right? So let's say if this is the neutral point, so electric field will come out and meet at the infinity. Okay, so electric field will come out and meet at the infinity. So this is the line of this neutral point. Understood, guys? So this is N, where the electric field is 0. Yeah, so understood, guys?
Yes.
Yeah.
Okay, so let us just quickly learn about this last property, which is the for the conductors. So for the conductors, electric field lines goes perpendicular at the conducting surface. Right. So if you have, let's say, this conductor, and let's say electric field lines are coming, so they will fall perpendicular, and then will go. This will not penetrate this conductor, right? But they will fall perpendicular and then come out of it perpendicular. Okay, guys, understood?
Yes.
Yeah, so this was all about this properties of the electric field line. So you see that how brilliant is this concept, that we were able to tell about the all the nature of the electric field through all these properties of the electric field lines, right? So curves, these curves were so brilliant that they told us about all the properties associated with the electric field. Right. So this is why these electric field lines, which are the hypothetical concept, but very important one. Understood, guys?
Yes, sir.
Yeah, understood. Yes, Aisha, Saad, and Mariam. Any doubt in any of the properties?
No, sir.
Okay.
No, sir.
Okay. So did you guys note down this seventh and eighth one? Did you guys note down this seventh and eighth one?
Yes, sir.
Okay. So now let us draw some electric field lines of some known electric field, right? So let's say you have this positive charge. So plus Q we already draw. Right, and for the negative charge, this would be the case. And let's say if positive and negative charge, so this is 1, this is 2, and let's say if you have this positive and negative charge. So this will come out of this positive charge, right? Okay, so this is due to this positive and negative charge, right? And what are the number of electric field lines? 1, 2, 3, 4, 5, 6, 7, 8. And here also 1, 2, 3, 4, 5, 6, 7, 8. So you can say that the magnitude of the positive charge and the negative charge is what? Same, guys, right?
Yes, sir.
Okay, so this is third one. And what about, let's say you have two positive charges. So you have two positive charges. So this will come, and so this is the neutral point. At this point, the electric field is 0. So this will come and go like this. Okay, so this is due to the plus and plus charges. And let's say, what about this dipole? Right. So for the dipole, we already draw. Okay, guys, understood this part. So this was all about this properties of the. So you guys just draw this part, and then we will learn about this force due to the electric field, in the presence of the electric field. So you guys just draw this part. Yes, did you guys draw this part?
1 second, sir.
Oh, sorry.
Sir,
Yes,
sir, can you
should I?
please scroll?
Yeah.
Done, sir.
Done. Yes, Mayam done. Saad.
Yes, sir.
Yes, sir.
Okay, so then the next topic is the force on a charged particle in the external electric field. Right. So in the next class, I'll be starting this Gauss law. So in the next 2 or 3 class, the chapter will be over. Okay. And for Saad and Mariam, I will take some extra classes to just revise what we have done in the class. Yeah, okay. So force on a charged particle in external field, right? So you have this first thing is that what is the uniform electric field? Right. So we have these electric field lines, right? And they are parallel. So this will tell, and the distance is always the same. So this will tell that the electric field is always the same. Okay. So this is a uniform electric field. Understood, guys? So if electric field lines are parallel. Okay, then the field will say to be the uniform electric field. Okay, guys. And what we do is that we put a charge in this external electric field, right? So we put some charge here. Okay. So if I put a positive charge, so this will experience the force in this direction, right? So this will be equal to QE, right? Understood, guys?
Yes, sir.
And if I put a negative charge, so this will experience a force in the opposite direction.
Minus QE.
Yeah, so this would be minus Q. Okay, so you see that the force is against the direction of this electric. Understood, guys? Yes. Guys, did you understood this part?
Yes, sir.
Yes.
Okay. Yeah, so we have two kind of forces for the different polarity of charges. Okay, so this was all about this force on charge particle in external electric field. We only need to know that what is the direction of the force for the case of positive charge and for the case of negative charge. For the positive charge, we have same direction. For the negative charge, we have opposite direction. Right. So there is a question which is related with this force, and this is added with this concept. So this is added with the concept of the kinematics. Right. And what is the kinematics? The equations of motion. Okay. So what is the question? The question is that there are two plates, right? And the electric field is in this direction. They are uniform. So this is the direction of the electric field, and one electron and one proton both move in this direction. So both are given some initial velocity and they both move in this direction. Okay. So we have to find out which will take a lesser time to cross this length. Okay, let's say the length is d. Right. So one is that proton is was given some velocity, and let's say electron was given some velocity. Let's say u in the direction of the x. Okay. So this we will do in the this question we will solve in the next class. Okay. The question is that who will take the lesser time to cross this electric field. Okay, so this is a question of this force on charged particle plus the kinematics. We have to keep in mind these two concepts, right? You guys already know that what are the equation of motion? Yes, what are the equation of motion, guys? Saad, tell me, what are the equation of motion?
V is equal to U plus AT.
Yes, correct. And the second one, Saad?
S is equal to UT plus half AT square.
Okay, so Mariam is answering Saad. What has happened to you? Yeah, so last question is for Saad, Mariam. Okay, so third was supposed to be Aisha, but yeah. So what is the third equation, sir? Do you remember or you forgot?
Forgot, sir.
Oh, okay. No worries. Right. So Aisha, what is the third equation? Yes, Aisha, are you there? You are there, right? So what is the
Yes.
third equation? Yeah, so what is the third equation?
V square is equal to U square
Yeah.
plus 2a.
Yeah. So these are the three equation and we will use these equation plus the concept of this force on charge particle. So this we will solve in the next class. Okay, guys. And in the next class, I will talk about this electric, so torque due to electric dipole, right? So torque
So
we
can
learned
you
in the, yes,
scroll up
yes.
for a minute?
Can you, what? I
Like,
couldn't hear.
can you scroll up for a minute?
Okay, okay, sure. So this concept will, so kinematics and this concept will use to solve that problem. The problem is that the electrons and protons are moving in some electric field, right? And we have to find out which particle takes the smaller time to cross this length of this electric field, right? So What kind? Okay, who left? There was a test, guys. So who left? Saad left. Saad. Yeah. So which motion we will use? The horizontal motion or the vertical motion we will use to solve the crossing time? Which motion we will use? Yeah. Okay, Saad has come. So Aisha, which motion we will use to solve this crossing time? The X direction motion or the Y direction motion? Yes.
Why?
No, we are crossing this distance D. D is in the X direction, right? We are not calculating this Y direction, right? So we are calculating how much time it takes to cross this electric field distance D. So D is in the X direction. So we have to use all the X component of this equation. So X equals to UXT and AXT square. So this we need to use. Okay, Aisha, Mariam, and Saad.
Yes, sir.
Okay, so we will do this question in next class. So you guys just please take that test. So open your Learnivio app, right? So do you have this Learnivio app? And log into your account. Okay. Then you will find. Okay, let me share the screen and tell you. So did you guys open that Learnivio account? So there will be a test
Yes.
Yeah, so you go to the class assessment section, okay? And there will be a test active. So just take that test. Okay. What do you guys want me to show that? Where is that active test? Did you guys find out the active test? And if you guys are not able to solve that, so I will discuss that in the next class. Okay. I forgot to discuss the question which Aisha did in the previous